In this video, we're going to explore a second example considering the difference between two sample means. And once again, we're going to use the Seaborn plotting tools for plotting categorized data. So typical imports up here, SNS is the Seaborn shortcut. And we have some details here about the actual study. So in this case, we actually know in advance that there were 9 mice and that they were all at some stage of having leukemia. And 5 mice were given a treatment and 4 were given nothing, so a control group. And what they looked at was the mice survival time in years from the time that the treatment was recorded. And so we do your usual load after running the first cell, of course. There we go. And we get the head of the data, so we can see the columns mainly, the ID, status, and survival time. Again, just to verify what we actually have, I'd be tempted to do the, let's look at the status. And if we look at the status and we ask for the value counts, so how many of each value do we have? We do in fact see 5 mice had the treatment and 4 had the control, so those are the labels that we're going to find. And again, it's worth plotting at the outset to see what kind of distribution we're looking at here. So we're going to use the SNS and that cat plot. And the nice basic input is just the X and Y coordinates. So thinking back to our last graph here, when we wanted the category on the X-axis, well, we just put the category as X, and that was our status, was the column name, and in quotes. And then our Y was the survival time. It's our numeric value. And we have to provide the data set. So data is equal to, here it's called data. All right, so we get our grid here, and all right, that looks reasonable. So again, maybe unlikely that these are different, especially the small sample size. We can also see this as a blocks plot, though with this low number of data points is probably okay the way it is. But just a reminder, we can say the kind of plot we want is a box plot if you want to change that structure for us. All right. So again, here, very little difference in the actual, these are medians, not means, but still they're quite similar. So I would be shocked based on the graphical analysis if we got a p-value that was indicated a difference. Again, should restate our goal here, or at least our null hypothesis. Both the treated and control mice have equal mean lifespans. That would be our null hypothesis. Treatment, no treatment, everybody's the same. You live for the same amount of time afterwards. All right. Well, really, we can just jump straight to the calculations. Let's recap the dissection of the data we had in the last one. And I'm going to grab all of that. So the data this time is based on just status. That's how we're categorizing them. Which different kinds of statuses, stati, do we have? We have treatment and we have control. So I'll grab treatment and I'll grab control. And we're getting extra spaces we don't want. We'll fix those in a second. There we go. Okay. So again, this inner part is selecting of the 9 mice, which ones had the treatment. Once we grab those rows, we're then going to look up their survival time in years. The second row, second data calculation, looks up all the control mice, all 4 of them, and says for the 4 control mice, what is their survival time in years? And then we run it. There we go. Again, just working through the logic here, this is 0.49, a probability of 49 times out of 100, or roughly 50 times out of 100. It is shockingly common that you'd see a difference this big between the means or bigger. In this particular case then, that's what the t-test is telling us. So here we would conclude, again, that there's no evidence that the means are different. Not no evidence, sorry. The evidence is weak if we tried to claim that the means are different. What we see in the measurements we made are fully in line with the hypothesis that both treated and control mice have equal lifespans. And so we have a nice simple answer here. We do not reject the null hypothesis. Okay. And that's a short and sweet 2-sample mean analysis.